Differentiation. In this video, we are going to focus on exam-style questions. You will find this on page 302 in the Namibian AS-Level Mathematics textbook, y equals mx plus c to success. Let's look at an example. This is the typical example that you will find in an examination. The diagram shows the curve, this is the function, and point A, 1, 0, there it is, and B, 5 and 2, lying on the curve. Find the equation of line AB, giving your answer in the form y equals mx plus c. Okay, we're going to do it on this method that we did in ordinary level. So basically, or more I think here in this AS level, we take the points. We call this point 1, point 2. So this is x1, y1, x2, y2. And then it is y, and then we use this formula. So it's y minus the 1s, and then 2s minus the 1s, x. So it's y minus 0, and I basically just do substitution there. Okay, I substitute. Then I simplify, then I cross multiply, and I get the equation of the line AB. Okay. Showing all necessary working, find the equation of the tangent to the curve, which is, and this is very important, which is parallel to AB. Okay. Okay, let's just get this again. So if lines are parallel, the gradients are equal. So if I look at this gradient is a half. So the gradient is a half. So basically, the tangent, the gradient will also be a half. Now, before I'm going on, so find the equation of the tangent to the curve. Now, if I want to always find the tangent, reflect back, I must always first differentiate the function. So I go into differentiation. Now, we can just, this function, we do the short method of the chain rule. Just get it in the form first to differentiate. Although this was, I just want to make it a bit bigger. Okay, I just want to see, this was just a half. Okay, so if I'm looking here, okay, I think I'm going to just show you from there. I like to show a little bit more in the videos. So let's just differentiate this. So if it was y equals x minus 1 to the power half. Now this is the chain rule, but first differentiate the outside. So it's a half, then it's x minus 1, and a half minus 1 or minus 2 over 2 is negative a half, and you multiply with differentiating the inside. Okay, and this is exactly what stood there. Okay, and then you can simplify it by saying, okay, I'm taking it down. And then I can basically just do this. Okay, and this is what I got there. Okay, let's just go on again. Now, after I differentiate, I know that the gradient must be a half. So I don't put 0. I don't want to find the stationary point. I know that the gradient is a half. I substitute. Then I simplify. I cross multiply again. I divide 2. I square, and then I'm going to get x is equal to 2. Because I divide 2, I get 1. And if I let me show you that step again. I like to, sometimes due to space, and also due to some students on this level, they don't need the extra steps, but it's not a problem if you need a little bit more. So basically, I'm just going to square this side and square this side. So it's going to be x minus 1, and it's 1. So it's x, and it's 1 plus 1. So it's 2, and that's what I got, the 2 there. Okay. And then, now, if x is 2 and I must find the y, always substitute in the original equation. And that was my original equation on top. So I get 1. So my coordinate point is 2 and 1. Now I can go for that tangent. I use this formula again, and I just substitute in the place of okay, don't forget, there I showed you also, but this is x1, this is y1. So in the place of y1, I substitute 1, and in the place of, I substitute 2, and then I just simplify it, and I got the tangent. Note, just for the interesting, because there is a 0, that it passed through the origin. This is important, maybe, for the steps to come. I'm going to make a bit first smaller. I just want to see if I'm finished with this stage. Yes. But let's just go to the second part, the third part. Find the perpendicular distance between the line AB and the tangent parallel to AB. Give your answer correct. Now, I made a nice sketch on the next page just to help you. Again, I'm going to make it a bit bigger. Okay. Now, if you look at this sketch, it's going to really help you. Okay, there's the curve. There's the line AB. Now, there's the tangent, and don't forget, it's going through the origin. Okay. Now, if I'm asking you in the previous question, let me just read it to you again. I don't want to go back. Find the perpendicular distance between the line AB and the tangent parallel to AB. It's that distance, okay? Give your answer correct. But before we go and find that, I'm first going to find now the normal to the, actually what I'm finding, I have 0, 0. I want to find this point here. Now, how do I find this point? If I work out, get the equation of the normal, I have the equation of this line AB. I can solve it simultaneously to get that point. A little bit of coordinate geometry. So the equation of the normal at the point 0, 0, I decided to take it here because I have that point. I know it's going through the origin, so 0, 0. So the gradient of the normal will always be perpendicular. So it was that half, can you remember? Let me rather write it first. This gradient is a half. So the gradient of the normal will be the reciprocal and different signs. Okay. So it is -2. Now, basically, if I'm going to look at this, I'm just going to, the gradient of the normal is now -2. Now, I take this point 0, 0, and I substitute it again. So I use my equation. Now, just take note, if you use this is correct. This is 100% correct for the normal. But then you must, if you substitute m, you must substitute the half. Otherwise, in the place of this one, you just replace -2. Okay. But otherwise, if you work with the original one, the original, it's a half. Let me just give you correct there. Which will then be -1 over 1 multiplied 2 over 1, which will give you that -2. Okay, put in the point, and this is now my equation of the normal that I indicated to you. Now I have this equation and I have this equation. Now if I solve it simultaneously, I can find that point. So the point of intersection between these lines, I solve it simultaneously. I get the x value is 1 over 5. Then I substitute it in one of the equations. Take the easiest one. This one looks the easiest. So -2, 1 over 5, and I get me. And there is my point. There is that green point there. And I have the point 0, 0. Now I must just find the distance. And think back of coordinate geometry. It's difference in x plus difference in y, and don't forget to square it. So this is almost like, okay, let's make it, let's just see if this was x, yes. So it's x2 minus x1, y2 minus y1. So this is going to be x1, y1, x2, y2. Okay. And if I'm going to work with that, I will get these answers. So the perpendicular distance between the lines and the tangent will be 0.45 units. Okay, I want to show you, you can also use trigonometric functions the tangent and sin or cosine to find the perpendicular distance using tan theta, using that gradient to find the angle. But I want to show it to you. So this whole method you can do different. I'm just going to make it quite big because I'm going to work on the sketch. Okay, I think this is better. Okay, so basically what I'm going to do is, and I'm going to use now different lines. Let's say this is 1. I can, from the previous, I know that this is point A. Just want to see that. And it's 1 and 0. So don't forget that this was point A and this was 1 and 0. Okay. Now, don't forget that this gradient of this line is a half. Okay, now if this is 1, then, okay, let's estimate, I say there will be 2. Okay, now what I want you to do, I'm going to do it now, is from there, I'm drawing a straight line. Okay, so let's call this is 2 now. Now, I also, actually what I want to find, and I'm going to use another color here, I want to know the perpendicular distance. Okay, now the perpendicular distance will make, okay, now I just want to use a pen, a ruler. Okay. I want to find that perpendicular distance. Okay. So basically, I'm going to start by first in this, let's call it blue triangle. Okay, into. Okay. Now, remember, and this is why I said tan there. If you have, okay, let's start. If you have, oh, I just want to use a pen. If you have tan theta, okay, why it's tan? Because don't forget, can I use here? What is the gradient? The gradient is delta y over delta x. So in this case, the gradient is 1 over 2, but that 1 is delta y. So that will be 1. And that will be 2. 2. So I can basically go and I can find this angle there. Did you see the blue? So if I want to find that angle, I will say tan theta. Why tan? Why tan? Because I have opposite over adjacent. And if you think, and I'm going to write it here, if you think of saw, car, if you have opposite and adjacent, it's tan. So if I have a half here, I can find that little angle there. So theta will be, and press on your calculator, shift tan bracket 1 divide 2 close the bracket equals. Okay, now I'm going to keep it to quite decimal places. It's 26 point, I think, let's just take it 565 degrees. Okay, I think that will be enough to make the final answer to 3 significant figures. Okay, now don't forget that for this red triangle now that I have here, now let me first show you where's my 90 degree again. Okay, now in the red triangle, where will be my 90 degree? My 90 degree can, and I'm going to even go and make it still bigger. My 90 degree, there is my 90 degree. Okay, now this is my, I have this, don't forget, this is the 26, just get the pen. This is the 26.565 degrees, that little angle there. Okay, now, but it's still the same for this red. Now, what do I have? I have this side, there's 1. So this side is 1, okay? What side do I want? I want this side. Do you see this red line? But let's name our sides again. So if I'm standing here, what will this side be? This will be my opposite. And the one over the 90 degrees will be my hypotenuse. Okay, so there's my hypotenuse and opposite. Now, okay, I can move it down just again, that you just see. Sokatua. Opposite and hypotenuse, what function am I going to use? I'm going to use sin. So I'm going to say sin of, now that is the red and the blue is the same angle, so 26.565 degrees, and that will be equal, what is opposite? Opposite is the one I want. Okay, that's the perpendicular. In this case, I don't want to call it x. I'm going to call it p for the perpendicular height. So p over, and my hypotenuse is 1. Okay, and then if you put it over 1, if you cross multiply, you will get p. Just press now sin 26.565 and times it with 1. So just press, I just want to see, sin 26.565 equals, and if I approximate it to, okay, in this 2 decimal places like in the previous example, I get p is 0.45, and that will be, and now I can make it all small, small again. Zero comma 45 units. So therefore, the perpendicular distance is 0.45 units. Okay, I just wanted to show you, then you can actually leave this and you can just do it on this method. Okay, that's what I was just explaining this note to you. Okay, I want you to stop the video and I want you to do number 1 and number 2, and you can continue the video as soon as you are finished. Okay. Let's start. Let's start to do number 1. Okay. At point A, the tangent to the curve, okay, there's the curve, there's the function, is parallel to the line. Find the equation of the tangent at A. Okay, now the first thing that you will do is you can first differentiate, okay, let's first write down the function. Okay, and if I differentiate dy by dx, and that's going to be 3x squared minus 18x plus 24. Okay, so basically, if I'm taking my line, what was my line? My straight line is y is equal to 2 minus 3x. Now the value in front of x, so therefore, what is my value? My value of m is negative 3. Okay, now if I'm telling you, I'm saying is parallel, the point tangent is parallel to find the equation of the tangent. So I'm telling you that this gradient is not the stationary point, it's negative 3. So in the place of that, I put that negative 3. And then I simplify it. And I get 27. Okay. And now I can, before I factorize, I can divide by 3. It's easier then. So divide by 3. And now I can factorize. And if I factorize, so 3 and the signs in it's negative, negative. So it's 0, x minus 3, x minus 3. So therefore, x is 3. Okay, now I must still go and I must find the coordinate point. So let's find the value of y. And don't forget, you always substitute in the original. So if, I like always to change colors now, just for you to see better. So if x is 3, y is equal to 3 to the power of 3 minus 9, 3 squared, plus 24, 3 minus 12. Okay, and if I press that on my calculator, that will be 27, that will be 981, 24 times 3, 72. So that will be 27 minus 81 plus 72 minus 12, and that will be giving me an answer of 6. So, okay, so let's just change colors again. The equation of tangent at A, 3 and 6. So basically, now I'm just going to use the straight line equation, and that I'm just going to write it down. So it's just going to be y minus y1 equals n x minus x1. And don't forget that this is x1, y1. So y minus y1 is equal to the gradient, negative 3, there it was, negative 3, and it's x minus 3. Okay, and this is going to be y minus 6 equals negative 3x, 3 times 3 plus 9. Okay, let's just move it up. So y is equal to negative 3x plus 15. And that will be, find the equation and tangent at A. Okay, and that's how you do it. Let's do number 2. First, let's just make space. Okay. So number 2, the equation of a curve, I just want to move this first over. The equation of a curve is this, and the equation of a line is this. Okay, so let's just write down that too. Equation of the curve and the equation of the line, make it another color, straight line. Okay. Okay, now where am I? The curve and the line intersects at point A and B. Okay, that's very important. So the midpoint of AB is M. Show that but first you must just find, this is the two lines, they intersect. Okay, so if I must find, I'm first going to solve them simultaneously. So what I'm trying to do, I get y, y. So I substitute 1 into 2. So it's like this, say this is 1 and this is 2 and it's, okay. Okay, so if I do that, I'm just going to say 9 minus 3x equals x squared minus 4x plus 7. So 0 equals x squared minus 4x plus 7 minus 9 plus 3x. So 0 equals x squared minus x minus 2. That is what I'm getting. Okay, now I'm going to factorize. If I factorize, it's 2 and 1 and 1 and 1. 2 minus 1. Biggest over cross product, it's a negative, positive x. So it's x minus 2, x plus 1. So therefore, put this equals 0, this equals 0. X is equal to 2 or x is equal to negative 1. Okay. Now I will go on and I must find the y values. So I'm just going to say if x is 2, always into your original, but take the easiest one. Why will you take the difficult one? So y straight line is easier. And that will give you 9 minus 6, and that will be 3. And that point will then be, I always just, that I don't get mixed up, 2 and 3. Okay. And then the next one, we can call this A, doesn't matter, it's the first one. Then the next one, we can say if x is equal to negative 1, y is equal to, again substitute there, and that's 12. And again, my point B will be negative 1 and 12. Okay. Okay, so we go on. The midpoint, but that's not A and B. So the midpoint, what is the formula for the midpoint? You're just going to add up the x values. It's actually, I will just write, it's x1, coordinate geometry. x1 plus x2 divide 2, y1 plus y2 divide 2. And that is going to give you 2 minus 1 divide 2. Sometimes I like this comma, but it's just a comma actually. Let's just do it better. And this is going to be 3 plus 12 over 2. So this is going to be a half, and this is going to be 15, and this is going to be 7.5. Exactly as they were telling me here. Show. So I showed. Okay. Let's see if I can move up. Let's move up a little bit. Find the coordinates of the point Q on the curve at which the tangent is parallel to this line. Okay, now if it's parallel, then okay, let's just see, this is B. Now, don't forget, you still need it in this format. So y is equal to negative 3x plus 9. If it's parallel, then the lines will be, the gradients will be equal. So therefore, m is -3 because parallel m1 equals m2. It will be the same. Okay. Now, what will I do now? I will go and differentiate and put that equal. So let's just see the line. There is the equation. So I'm going to, okay, let's just write it down. Get my colors correct. What is the equation? The equation was x squared minus 4x plus 7. So dy by dx is equal to 2x minus 4. Okay, and now this is the gradient, so I substitute the gradient in, so -3 equals 2x minus 4. So if I bring it over, so it's going to be -3 plus 4 equals 2x, and it's 1 equals 2x, so the value of x, so therefore x is a half. Okay, and now I must find, okay, let's just see. I'm going to say find the coordinate of q, so I must still find the value of y. So if x is a half, always in the original, this is your original, okay, then y is equal to a half squared minus 4 a half plus 7. And if you're going to press that in, you're going to get minus 2 plus 7, 5 1/4. So therefore, what is the value of q? The value of q is a half and 5 1/4. Okay, and then find the distance mq. Okay, now I'm just going to, for finals, because you have both, I'm going to move it up because it's not so it's almost done. So I'm just coming in with C. Okay, so what was m? M was given, that was that half, and it's 7.5. And there is q. Okay, so distance, how do I find distance mq? And I think I showed you. So if I'm going to, for the distance mq, it's the difference, and I'm just going to, I'm not going to write, but I always like to, I always like, then I don't make mistakes. Let's call this, it's both of them. So this is going to be, let's call this x1, y1, x2, y2. So it's the difference in x squared. Okay, now the difference, so it will be a half minus a half squared plus the difference in y squared. 5 1/4 minus 7.5 squared. So this is becoming 0, but luckily that one is still there. So it's 5 ABC 1 ABC 4 minus 7 ABC 1 ABC 2 equals, and then square equals, and then the square root equals, and that will give me 2 1/4. Move it up. So this will be 2 1/4 units. And that will be the distance between M and Q.